And I handed out the note already, right? So we have the note. All right, so let's take a look at applications. The first thing we need to know when we're doing applications is the base formula. What you're going to do today for all the different kinds of applications is you create the formula or the equation that you're going to use for the particular application, and by subbing in the numbers, and then use your formula to solve for something. Okay, that's how this is going to work. So the first couple of examples we're going to look at are going to be exponential growth, and we'll look at some examples of exponential decay as well. It's just a small difference, otherwise it's basically the same thing. So this is the general equation for an exponential growth or decay application. It's got a lot of variables in it. 1, 2, 3, 4, 5. For all of the applications we're doing today, they're all pretty simple and straightforward. When we come back in a couple of days and do more applications, they'll be a bit different, but for now, they're all pretty much the same. And so we're going to have most of these variables are going to be, the value is going to be given to you in the question. Okay, but this is something you need to know. You 100% need to know this formula. So what are all of the details? That's what we're going to write down first. What is A? A is the final amount. We're going to do, I think, 5 examples, and they're all a little bit different. So you're going to see all the different kinds of things that exponential applications can be about. They can be about interest, finance. They can be about other money value things. They can be about, there's questions about half-life, questions about populations, all different kinds of examples. So if you're given an equation, like in a different circumstance, I think all of the examples today, you're making the equation, but if you're given an equation, it might not be A, it might be something else. If it's population, it might be a P. If it's talking about bacteria, it might be a B. So you don't have to use the letter A, but it's whatever thing goes there, that's the final amount. And this is A with a small, it's called a subscript. It's a small little zero like this. You've seen this before in when you do slope formula y1 and y2 and x1 and x2 and that kind of stuff in grade 9. Sometimes it's referred to as naught. It's kind of a British thing, but it would be A naught. It means like, but it means kind of the first is usually what it means. And in this case, it does mean the initial amount. So A naught is the initial amount, whatever it starts. Again, applications are like word problems, right? So you're reading through and you have to, and these ones are pretty straightforward. They're not really confusing usually. But you got to decide what's the original amount and what's the final amount. Like that is part of what you have to figure out. And what the initial amount goes there and the final amount goes there. Okay. And amount of what? Well, again, whatever the question's about. So if the question is about money, then it's the starting amount of money and the final amount of money. If the question's about population, it's the original population and then the population in the end. Okay? R is the rate of increase or decrease. It has to be as a decimal. So if we're not given it as a decimal, we turn it into a decimal. Sometimes it's given as a percent. And there's a couple of kinds of questions where you're actually not given R, you're given this whole thing. So when we get to those questions, we'll talk about them. I think they're at the end. Okay? And so that is part of working with all of this, is figuring out R or figuring out whatever this whole bracket is, which is like a multiplier. So figuring out what the multiplier is and getting that part done properly is a place where people might kind of make a mistake. Okay, so we've got A naught, we've got R, now we got to do T. What is T? T is going to be some length of time. And N is also a length, but it's a little bit different. It's the length between increases or decreases, whichever one is happening in the situation that you're looking at. So, and again, I think the first few examples, we don't really have to worry about it. It doesn't really come up, but then it'll come up, and when it comes up, it'll make a bit more sense, and we'll talk about it. These two definitely have to be in the same units. So every question is going to have a whole bunch of stuff to it, and then it's going to say so-and-so increases every year, or every day, or every hour. And so both of these would have to be in years, days, or hours, whatever it is. Or it might say every 2 hours, or every 3 years. And that's where N comes into play. If it's every 3 years, your N would be 3. But we'll talk about that when we get to an example that includes it. So far, so good? Okay, our first question is about compound interest. And part of it is, I think it'll usually be obvious, but like everybody's different, right? So you do have to decide, is this increasing or decreasing? And part of that is going to be like real world thinking about this stuff. If you have money in the bank and you leave it alone, obviously if you spend it with a card or something, it's decreasing, but that's not what we're talking about. If you have money in the bank and it just sits there with interest, does the amount go up or go down? It goes up. So this is increasing, right? Interest adds on to your account. So it says you deposit $1,000 into a bank account that pays 5%/A. That means, and when it's interest, it often has that. It means per year. Interest rates are almost always given per year. So that's just a standard. And if we had more time to get into this, this is what we'd be doing more of, is more compound interest in finance stuff. But fortunately, we're going to run out of time. Okay, and then compounded annually. So that means that just means once a year, every year. So our N is 1 for this. And for compound interest, for interest ones, it always will be. How much do you have after 1 year, 2 years, 5 years? So the first thing we have to do is come up with our equation. So we're going to do that first. And to do that, we list out all of the variables. Like that. And you can either, and again, everybody will have a different preference. You can do them in order, or you can go through the question and read through it and start taking numbers out of the question and plugging them in to where they go. Okay? So I already told us N is 1, so let's get that out of the way. You deposit $1,000 into a bank account. So where does the $1,000 go? That's the initial amount. Very good. It pays 5% interest. So that's the increase. That's your rate. That's your R. But it has to be a decimal. It's given as a percentage. So what do? I do 5 divided by 100. Let's see what that looks like. Oh, hopefully it gives the right camera here. There we go. Nice. So you literally do 5 divided by 100. I'm going to zoom in a little bit and focus because it looks a little out of focus. That's better. Hit equals. It better give it to you as a decimal. If your calculator gives it to you as a fraction, you turn it back into a decimal, 0.05. Okay, and that's the number that we actually want. Whoops. Wrote that backwards. That was weird. A is when it says how much do you have after a certain amount of time, that's your final amount. So I like to put a question mark in the place of like what we're solving for. And T is going to be all these different things. So it's going to be 1, and then it's going to be 2, and then it's going to be a 5. You can just leave that blank if you want, but it's going to like, because we're doing this 3 different times, T is going to be 3 different things. Okay? So this is part of your solution, is writing this out. So some of you might want to just go straight to the equation, but I want to see this part, okay, on a quiz or a test. I want to see that written out. Now we can go ahead and plug them in. So A we don't know, so we're just going to write A. The initial amount, A naught, is 1,000, so that's 1,000. 1 plus the rate, which is 0.05. To the T, because that's going to change, and it's over 1 in this case, so you don't really need to write it, but I'm going to get in the habit of kind of remembering that there can be a number there. And then I'm going to write this again to simplify. 1.05, you can do that on your calculator if you have to. Sometimes you might have to. Sometimes you might be able to do it in your head. To the T. And I'm not going to write over 1 again, so now that's good. And that's our equation for this question only. So you see what I mean? A big part of each one of these questions is coming up with that equation. Then we're going to use it. So question A is for 1 year. That means T equals 1. A equals 1,000 times 1.05 to the 1. So that's 1,000, and depending on your calculator, it's going to look a little bit different. 1,000 bracket 1.05 bracket, and we don't need the exponent 1 in this case, so you can put it or not, that's up to you. But to the exponent 1, I hit equals, and I got 1,050. So you made $50 in interest for doing nothing, but it took a year. That's not great, but hey, it's better than nothing, right? And normally you would finish these with a therefore statement, but when there's 3 of them, it gets kind of tedious. So I'm actually going to, we'll see that in a different example, but I'm actually going to say we earned $50. Actually, that brings up a good point. What if so the final amount is $1,050, but you already had the $1,000. So you made $50 extra. That's not what the question is asking. The question is saying, how much do you have after a certain amount? So your answer would be, therefore, you have 1,050. But what if the question said, how much did you make? How much more do you have after? Then you'd have to answer the question carefully. Okay, so just be careful of that. But there's a reason why I'm just going to say we earned $50 in this case. Question B is after 2 years. So that's at T equals 2, and we do the same thing. 1.05 to the 2. So if I made $50 in the first year, presumably you'll make $50 in the second year again, and so we'll have 1,100. Is that what we might think? You might think that, so let's check it out and see. 1,000 bracket 1.05 bracket squared. And we're wrong. If we thought that, we were wrong. It's not 1,100. If I added another $50, I'd be at exactly 1,100. I'm a bit more than that. Why? Well, this is how compound interest works. That's why it's called compound interest. And this is how exponential growth works. And the reason why, so you actually earned in the second year only, you earned $52.50. The extra $250 is what? Anybody have an idea? That's the interest on the $50 that you earned in the first year. Okay, so this is how compound interest works, and this is how, like I said, all exponential growth works, but it's most interesting for compound interest, is after a year, it compounds, means the bank actually gives you the money, and you start earning interest on the interest as well. That's how it works, which makes sense. Okay, so anyway, so it's interesting. First year you earn $50, second year you earn $52.50, third year you'll earn even more than that. So it grows, but how fast it grows too. And if you think about the exponential curve, that's why it's not like a straight line going up, it curves up. Okay. Okay, C is at t equals 5 years. Okay, so I get 1,000 bracket 0.05 bracket to the 5. And then you often these questions, you get a decimal and you got to round it. And there's money, so it doesn't say what to round to. So what do you think we should round to? Probably 2 decimal places because it's money. So a lot of these questions, it's not going to tell you what to round to because you got to kind of think about it and figure it out. Sometimes it will tell you, whoops, 0.28. Therefore, I have $1,276.28 after 5 years. We're not going to write therefore statements every single time, but that's what it would look like. Any questions? What do you think? So this is population growth. So this is a population that's increasing, and it even says it in the question. So again, in some cases it's pretty clear, it's obvious if it's growth or decay, but not necessarily always. Town of Jordanville has a population of 190,000 people and is growing by 2% per year, each year. Not every 2 years, not every 3 years. So this is telling me n equals 1. Okay, that's what that means. It's more obvious when n isn't 1. Usually if n isn't 1, as long as you understand it, it's pretty obvious. Question A, create an equation to model the growth of the population, and then we're going to use our population to predict, use our equation, to predict the population in 5 years. So again, we're going to go A equals A naught equals R equals T equals and N equals. We're finding the population in 5 years. That's the final amount, so there's a question mark. The initial population is 190,000, so that goes there. The rate is 2%, so it's 2 divided by 100. Again, when you use your calculator, you get 0.02. In part B, T is going to be 5 years, so you can add that in or not. And N, as we already said, is 1. So when I write my equation, it looks like this. A equals 190,000 bracket 1 plus 0.02 to the T. Like we don't put into the 5 there. We're only doing it once, but we still always put it to the T because that's like our X. And then I can, oh, and it's over 1 again. You don't need to write that, but 0, 0, 0 to the 1.02 to the T. And B is when T equals 5. So go ahead and try that. So the answer I got on my calculator is 209,775.3526. Again, it doesn't tell us to round to, so what do you think we should round to? What should we do? Right, no decimals because it's people. You can't have part of a person. You can't have 0.35 of a person. Okay, some people are like, oh, baby or something. No, they still count as a human being, even if they're not very useful. Okay, so whoops, we already did that part. So this would be approximately 209,775. And that's an approximation. It's not going to be an exact amount. You can't say that for sure. When populations grow, they grow by approximately 2%. It's not going to be exactly 2% every year. So whether it's 770 or 774 or 776, like you wouldn't know, but that's a prediction of what would happen. And we'd say, therefore, at 5 years, there are or the population is, or something like that. All right. Any questions? Moving on. Exponential decay. What's the difference in the formula for exponential decay? Yeah, you're subtracting the rate. That's the only difference. Everything else is the same. So let's take a look at an example of that. Depreciation. The price of a new car is $32,999. It loses 30% of its value each year. Part A, write an equation to model the value of the car over time. So why don't you see if you can fill as many of those in as you can. Okay, so this is what I got so far. It loses 30% of its value each year. So there's your n equals 1. The starting price was $32.99, so that's the initial amount. You're looking for the final amount. T is going to be 4, but we don't start with that. We just leave it blank. T is T. And the rate is 30%. 30 divided by 100, which gives you 0.3 in this case. So A equals 32,999. And remember, it's losing 30% of its value. So it's decreasing, so it's decaying, it's getting smaller, so you're subtracting 1 minus 0.3 to the T over 1, or T. And then you can use your calculator if you want to do 1 minus 0.3, and you get 0.7. Part B is when T is 4. And again, it's money, so we would round to 2 decimal places. it was 0.599, so round to 0.6. That is an incredible loss of value. 5 years. Isn't that amazing? The car is worth, and that's true. That's accurate. That's about, I mean, every car is a little bit different, but I think that's what they go by, is cars drop in value about 30% every year. And that's why they say, like, buying a new car is a terrible investment, because the first year it loses its most value. A brand new car is worth more just because it's brand new. So even a 1-year-old car, you can save a lot of money on it. And it depends on other things, like if there's an accident or how many miles it's been driven or kilometers, that kind of thing, right? But generally speaking, all things being equal, 30% per year. So if you can find a 1-year-old car or a 2-year-old car, that's typically that's been taken care of. That's a very good investment. My mother-in-law was recently in a car accident. She had a Volkswagen Tiguan. It's their SUV. It's a pretty nice car. Probably $40,000 to $50,000 is about where they would start, and then when you start adding things onto it, it gets more expensive from there. Obviously, hers was she got it from sort of a friend, so it was lightly used when she got it, but it was probably, I think, only 3 or 4 years old. Okay, and she got rear-ended. Damage didn't look terrible, but there was damage, and it was going to cost $15,000 to fix it. So this is a 4-year-old car and a nice car. It's going to cost $15,000 to fix it, and they wrote it off because they said the car was only worth $13,000. So they gave her $13,000 for this perfectly good 4-year-old or 4 or 5-year-old car. I think this is like 4 years old, maybe 5. Crazy. That was probably worth 50 or maybe even 60 when it was first purchased by the original owner. I think they were kind of surprised to hear that it wasn't going to get fixed. Anyway, there you have it. That's what happens. Next example. Okay, so now we have to decide. Now it starts to be, we decide whether this is an increase or a decrease. Okay, and these are two specific kinds of examples. They are both, the next two that we're doing are both a little bit different. They're specific ones that you want to be familiar with, I guess I would say. Okay. This is kind of gross. The bacteria on your math homework doubles every 2 hours. So this is already different because it's every 2 hours. And that's where n comes into play. It's not every hour. It's telling us when it grows, the rate that it's giving us happens every 2 hours. Last one was every year, every day, every week, whatever. This is every 2 hours. That's your n. Okay, so that's what you're looking for. The current population, there is a current population of bacteria of 400 on the math homework that I'm going to give you in a few minutes. 400 individual bacteria on it. Okay, part A, create an equation to model. So again, A is what we're looking for. The initial amount is 400. Oops. I'm going to leave the rate blank for a minute. Okay, we're going to come back to that. T, again, we're going to have a couple of different T's. And n is 2. So this is the first time we've had an n value that's not 1. So it's going to be 400 times something to the t over 2. And here's the trick to these ones. It doesn't give us the growth rate as a percentage. It's giving us the multiplier. It's saying that it doubles. So I put a 2 in there. So for these ones, I'm fine if you just put a 2 in. But what it's saying is you have 100% growth rate. It's doubling. It's growing by 100%. So if you were to figure out the rate, it'd be 100 over 100, which is 1, and it'd be like 1 plus 1, so it'd be 2. Okay? But for these ones, you can just leave R blank, and you can put a 2 in there, or if you want, you can say it's 100% growth. It's up to you. But sometimes these population questions are tripling, or quadrupling, or growing by 5 times or 10 times the amount. Okay, so in that case, if it's tripling, you'd put a 3 in there. Quadrupling, you'd put a 4. Okay, so this is at t equals 2. Now think about this one. The bacteria doubles every 2 hours. And it's after 2 hours. So how much bacteria should we have? 800. It's doubled. This should figure that out for us. And I'm going to do this to the 2 divided by 2 is 1. So it's 2 to the 1. So it's 400 times 2 once. So it's going to be 800. What if it was 4 hours? You don't have to write this down. You can just maybe just watch. It'd be 400 times 2 to the 4 over 2, which is 400 times 2. 4 divided by 2 is 2 to the 2. And what does 2 to the 2 mean? It means 400 times 2 times 2. 2 squared is 2 times 2, right? 2 cubed would be 2 times 2 times 2. So it's doubling twice. 400 times 2 is 800. Times 2 again would be 1600. So if you're kind of thinking about why this equation works, it makes sense. Okay, let's try 24 hours. So some of these you can do in your head, but definitely not one like this. 400 times 2 to the 12. 2 to the 12 is a pretty big number. And when you multiply it by 400, you get 1,638,400. Therefore, yuck. It's disgusting. Bacteria does actually kind of double that way, because if you know, if you've taken any biology or anything, when like a bacteria cell doubles, right? It splits into 2 cells. That's how it grows. So one bacteria after 2 hours will split into 2. And now you have 2 that will split into 4. Now you have 4 that will split into 8. So it's doubling. Like that's what's happening here. So it would grow quickly. Again, it's not going to be exactly every 2 hours, but bacteria, as long as there's enough like food or whatever for it to eat, to live off of, it will continue to double and keep going. Last example we're going to do is a special one. It's called a half-life question. Again, this is one that you just need to be familiar with. And this is usually talking about substances, chemical substances. Okay, elements. If you've taken any chemistry, which I'm sure all of you have in science, talked about the periodic table of elements. This is talking about different types of elements. So iodine 131 has a half-life of 8 days. So the half-life occurs every 8 days. So what does that mean?
Every 8 days it goes down by half.
Very good. So what is that telling us about our equation? The 8 is going to be our N. So again, we're looking for the final amount. It says the initial amount. Oops, I don't want that to open. You start with a 320 milligram sample. So our starting amount is 320 milligrams. Our rate, again, we can leave that blank for now, is blank, and N is 8 because it's every 8 days. So half-life questions usually will have some kind of an N. Okay? And it's being cut in half. So for half-life questions, your multiplier is always a half. It's being reduced by 50%. So 50 over 100 is a half, or 0.5. But half-life question is always like that. It's the point of a half-life. To the T over 8, or 320, you don't have to write it twice, 0.5 to the T over 8. If T is 16, what does that tell you about this? If the half-life is every 8 days. After 16 days, what will have happened? Not double, because it's decreasing, it's half, right? Half-life, I didn't actually say that, but half-life is being cut in half. So what's happening is when this is a radioactive element, so it's radioactive decay, and you know the word radioactive means bad, like it often is harmful. And so, but what's happening is when the radiation takes place, it's changing from iodine to some other substance. That's what the decay is. And usually it doesn't actually disappear. It just becomes something else. And it lets off a dangerous radiation when that happens. Okay? So after 16 days, if it's every 8 days, that has occurred twice. The first 8 days, it cuts in half. The second 8 days, it cuts in half again. So we've had 2 half-lives occur. And we'll see that happen in the equation. Because it'll be 16 over 8, which is 320 times 0.5 to the 2. 16 divided by 8 is 2, so to the 2. So 2 half-lives. That means I take 320 and cut it in half once, which would be 160. Cut it in half again, which should give me 80. And when I punch it into my calculator, sure enough, that's what it's going to give me, times 0.5 to the 2. So 0.5 squared, and it gives you 80. Any questions about this so far? We got one more little question here to do. 8 weeks. What's the problem with this?
T has to be in the same variable.
Right. So everything we've done up till now is in days. So 8 weeks, 7 days in a week. 8 times 7, 50 is 56 days. So you just got to make sure that you're not rushing and that you're reading carefully. So T is 56. (56) divided by 8 gives me 7 again. And when I do that, I get 2.5 exactly. Now, sometimes these half-life questions end up being really small or nasty decimals. So you might be told to round, and you'd be told what to round to in this case, or you might put the whole thing sometimes. And it makes sense to have a decimal. You can have 2.5 milligrams, right? That's what it means. 2.5 milligrams of the substance are left. You can have a decimal of a milligram, okay?